right, so today we are going to be talking about even and odd functions. So by the end of this video, you should be able to prove that a function is even, odd, or neither. So let's just do a little bit of exploring. So let's compare f of 2 to f of negative 2. So f of 2 looks like it is 5, or 8. Oh yeah, that's 2, 4, 6, 8, not 2, 3, 4, 5. 2, 4, 6, 8. F of negative 2 appears to be 8 as well. F of 3 appears to be 13. F of negative 3 appears to also be 13. So what conclusion can we draw? It appears that f of x is the exact same thing as f of negative x, since we saw f of 2 is the exact same thing as f of negative 2. Both were equal to 8. That means that this function is even. So even functions have this property, that f of x is equal to f of negative x. Visually, even functions are reflections over the y-axis. So since this function here is a reflection over this y-axis, it is even. Now let's take a look at another graph. F of 1 compared to f of negative 1. The value of f of 1 appears to be negative 2. The value of f of negative 1 appears to be positive 2. F of 5 appears to be negative 2. F of negative 5 appears to be positive 2. So our conclusion here is that the opposite of f of x is equal to f of negative x. So as we see, f of 1 equals negative 2, then f of negative 1 is equal to positive 2. So f of negative x is equal to the opposite of f of x. This property here is a property of odd functions. Visually, on a graph, odd functions are reflections, 180-degree reflection about the origin. Easiest way to determine if something's reflected about the origin is to take your paper and turn it upside down. If it ends up looking exactly the same when it's upside down, it is a reflection over the origin. So for example, if I take this graph here and I rotate it 180 degrees, it's still the same graph. That means it's a reflection about the origin. You can actually move your paper. I can't, so I have that instead. All right, so let's take a look at this third graph. So let's compare f of 1 to f of negative 1. Since f of 1 is 2 and f of negative 1 is 1/2, f of 2 is 4 and f of negative 2 is 1/4, this is neither even nor odd because it doesn't fit either relationship. All right, so let's take a look at these graphs and let's classify them based on their graph. So this graph here appears to have symmetry about the y-axis. So that means that it is even. This graph here appears to have symmetry about this line here, so not quite the y-axis, so that's neither. This graph appears to have symmetry about the origin, so odd, and this graph appears to have symmetry about this point right there, so that's going to be neither. So that is how you determine from a graph whether a function is even or odd. And you could take point values too. This graph is just really hard to read, so it's hard for me to determine what these values are to look at the actual numerical values like we did at the other example. So I went with symmetry. So how do you determine if algebraically the function is even or odd? So that is going to be this relationship here. We're going to look to see if f of negative x gives me f of x, or if f of negative x gives me the opposite of f of x by substituting in negative x. So substitute in negative x into my equation, and I end up getting negative x to the 6th power minus 2 times negative x squared plus 3. So negative x to the 6th power is x to the 6th power. Negative x squared is x squared times negative 2 is negative 2x squared plus 3. So we end up getting x squared minus 2x squared plus 3, which is f of x. So since f of negative x was f of x, that's the property of even functions. Next example, f of negative x. So we substitute in negative x, we get negative x cubed minus 3 times negative x. Negative x cubed is negative x cubed. Negative 3 times negative x is positive 3. So we have the opposite of f of x. Notice every sign has changed. So f of negative x gave me the opposite of f of x, and that means it's odd. Next example, substitute in negative x, and we end up getting 7x squared minus x plus 1. That is neither the same nor the opposite, so neither. 4x to the 4/5, substitute in negative x to the 4/5, so that means the 5th root of negative x to the 4th, so that means negative x to the 4th is x to the 4th, so x to the 4/5, which is the same, so even. 2 times x squared minus x, substitute in negative x, we get positive 2x squared plus x, which is neither the same nor the opposite, so neither. And our last example, substitute in negative x, and we get negative x cubed minus 2 times negative x, which is negative x cubed plus 2x, which is the opposite, so this is odd. Graph the function h of x on your calculator, sketch the graph, and determine if the function's even, odd, or neither. So we type this into our y equal, we graph it, and you might want to pause if you, because I'm going to show the answer now, until you get the answer, then resume. So we get a graph that looks something like that. So compared, looking at the graph, I'm going to look at symmetry here. It appears that our symmetry is with the y-axis. Looking at the table, we can verify as well that this is an even function. And number 8, compare the functions. F of x equals log of x squared, and g of x equals 2 times log of x. Using the definition of even odd functions, write a conclusion. So f of x equals log of x squared. So if I substitute in negative x, I get f of negative x squared, which is log of x squared, which is even. Looking at g of x, I get 2 times log of x. Substitute in negative x, that's 2 times log of negative x, which is neither. So the function f of x equals log of x squared is even function, but the rewritten form is not. Interesting, right? Because using properties of logs, this and this should be exactly the same, but if we're going back to just plain graphs, that's not necessarily the case, that this graph here, oh my goodness, this graph here and this graph here are not the same graphs. Special properties. So the sum of 2 even functions is even, the sum of 2 odd functions is odd, The sum of an even and odd function is neither even nor odd unless the function's 0. Product. The product of two even functions is even. The product of two odd functions is even. And the product of an even and an odd function is odd. So we have even plus even is even, odd plus odd is odd, even plus odd, nothing. Even times even is even, odd times odd is even times odd is odd. So let's go ahead and let's try these. Which of the following function is even? So the first one, we have an even plus an odd, which is nothing. Even plus even, which is even. Odd plus odd, which is odd. Odd plus odd, which is odd. So our answer is g of x. And if you're like, how am I knowing these are even or odd? I'm looking at the exponents. X to the fourth is an even function. X to the third is an odd function. Which of the following functions is odd? So here we have an even plus subtraction, so plus a negative. Odd, which is nothing. Here we have an even plus an even, which is even. Here we have an odd plus an odd, which is odd. And here we have an even plus an even, which is even. So our answer is h of x, which is odd. Which of the following products is even? So let's see, f of x is x squared plus 1, so that's even. G of x is x to the third minus 3x to the first, so that's odd. And h of x is x to the fourth minus 4x squared, so that's even. So I have an even, odd, even function. So if I take f of x times g of x, that's an even times an odd, which is odd. G of x times h of x, that's an odd times an even, which is odd. F of x times h of x, that's an even times an even, which is even. And f of x times g of x times h of x is even times an odd, which is odd, times an even, which is odd. So we have C being our answer, f of x times h of x. Example 12, x squared plus 1 is, oh, I didn't have those marked off. Oh well. The same exact functions almost as before, but the last one, we have 3x to the fifth plus 2x to the third, so that's an odd plus an odd, which is odd. So let's see, f of x times g of x, so that's an even times an odd, which is odd. F of x squared, so that's even times an even, which is even. G of x times h of x, which is odd times an odd, which is even. F of x times g of x times h of x, so that is an even times an odd, which is odd, times an odd, which is even. So our answer is A. The function shown in the graph is, let's take a look. Taking a look at this, we look like we have symmetry about the origin, so odd. The graph of the function, looking at this, looks like we have symmetry about the y-axis, so that's even. Here, it doesn't look like we have symmetry with the y-axis or the origin, so neither. Which of the following sum is odd? So again, taking a look at this, we have odd plus odd is odd, odd plus odd is odd, even plus even is even. So we have odd, odd, even for those functions. So f of x plus g of x is odd plus odd, which is odd. F of x plus h of x is odd plus odd, which is odd. Sorry, f of x plus h of x is odd plus even, which is nothing. G of x plus h of x is odd plus even, which is nothing. And f of x plus g of x plus h of x is an odd plus an odd, which is odd plus an even, which is nothing. So our answer is A. Which of the following is even? So f of x is odd plus odd, so odd. G of x, odd plus odd, so odd. H of x, even plus even, so even. And here we have odd plus odd, which is odd, plus even, which is nothing. Odd times odd, or no, odd times even, and then plus odd, so that's odd. F of x times g of x, we have odd times odd, which is even, plus even, which is even. And then g of x times h of x, we have odd times even, which is odd, plus odd, which is odd. So our answer ends up being C. And 18, we have odd plus odd, which is odd, even plus even, which is even plus even, which is even. So we have f of x times g of x, which is odd times even, which is odd plus even, so nothing. F of x times h of x, so odd times even, which is odd, plus even, which is nothing. G of x times h of x, which is even times even, which is even, plus f of x, which is odd, so nothing. So our last example, f of x times g of x, which is odd times even, which is odd, times h of x, which is even, so odd. So our answer is D. All right, I hope you found this video informative. Your homework tonight is to do the corresponding worksheet and then fill out the Google form when you are done. In the meantime, I have office hours on Friday, so if you have any questions, you're welcome to see me there. In the meantime, stay safe, stay sane, and please stay distant. Bye.